Greetings. This is the second video in this brief series on research methods in psychology. And this is the second video of us talking about experimental methods. So in this video, I'm going to talk about variables and a few other concepts. So a variable, one way to think about a variable is a thing. Just replace the word variable with thing, and I think that will help you. So in every experiment, almost all experiments, what we're going to see is a dependent variable and an independent variable. And this can get confusing. The dependent variable is the thing that we're measuring. So we want to know if there's going to be a change in violent behavior, right? Whether there's going to be more or less violent behavior. So that's the thing that we're going to measure at the end. Right? When we're all done, I don't know, we'll try with one group, maybe we'll give them videos that aren't violent and another group videos that are violent, right? And the non-violent videos would be our kind of a placebo. It's similar, but it doesn't have the actual content that we're measuring. And we would measure violent behavior in the end, see if the violent behavior of kids who got videos that are not violent and kids who got ones that are, we measure and compare, right? So the dependent variable is the one that we're measuring. The independent variable is the one that we're manipulating. In our case, violent video games. In other words, one group is going to get them and one group isn't. That's the one we're manipulating. The independent variable in another experiment might be the drug. So let's say I want to know if Prozac cures depression. I give one group the drug, Prozac, and one group a placebo, right? So the independent variable is the drug. I'm manipulating it, right? The dependent variable in that case would be depression. We're going to measure depression in both groups at the end. We want to see if it's affected. This takes some getting used to. You can always refer back to this slide. An extraneous variable is anything that could change or affect the result of a situation or an experiment. So for example, what if the kids are watching violent movies? That would be another variable that could mess with our data. What if the kids are seeing violence at home? That could mess with our data. What if, I don't know. I can't think of another one. But those are extraneous variables. If we were measuring sleep, for example, we want to know if coffee makes you not sleep. Okay? So we measure sleep in the end, right? How much are you sleeping after you drink coffee? Well, what if your neighbor has a barking dog? What if you have a new baby? What if your bed is uncomfortable? All those other things would be extraneous variables, and you have to account for them. You have to think about what you're going to do with them, right? So those are extraneous variables. And we have some other important concepts that you should be aware of. We want research to be reliable. So for example, right now we are looking at COVID vaccines, right? So one of the ways that the vaccines are tested is we want to see if, that's actually not a great example. It's more complex than that. So let me think of something else. Let's say we set up an experiment to see if we can, this actually happened, an experiment to see if we could clone a human. And there was a group that claimed, this was a few years ago, they claimed that they had done it, that they had cloned a human from some cells. They created, it wasn't a whole human, it was parts or something, parts of a human. And so they published their results, right? And when they published their results, they also published their method. How did they do it? And they have to be very, very specific. Now, in order to see if their method is reliable, we have somebody will repeat that. Somebody will follow their instructions, do exactly what they did, and see if they get the same results. And what happened with this group was actually some other researchers repeated their research and did not get the same results. It did not work. And what turned out was that they fabricated it. They lied. So the group that said that they had succeeded in cloning human parts, they lied. And this is how we know. Now, sometimes it's not people lying. Sometimes they make mistakes or there are coincidences. So when we try again, we can rule out coincidences, mistakes, and lies, right? Okay. Validity tells us that the experiment measures what it claims to measure. So, for example, we talk about intelligence tests in psychology, right? So an intelligence test is supposed to measure how intelligent you are. But what we have found is that intelligence tests sometimes, and parts of them are not very good because they don't measure intelligence well across, say, racial or economic divides. So people from affluent homes who might be white and who might go to, excellent schools will measure higher on intelligence tests than people of color who might be from a poor neighborhood or may have not gone to a good school. Any of those things combined, right, might lower somebody's intelligence quotient, their IQ score, right? Well, then you're not measuring intelligence. You're measuring something else. You're measuring environment. So that would mean that the test might not be entirely valid. It might not always measure intelligence, right? Okay, representative sample of the population. So I want to know if, we talked about intelligence tests. I want to know if they are, if they work. If I have a good intelligence, no, that's complicated. Let me try that again. I want to know if a drug works. I want to know if Prozac cures depression. Let's keep it simple, right? So I get some test volunteers, right? And I get a group of, say, 1,000 test subjects. And I test my drug on them. But what if all of my test subjects were college students? What if they were all male and white? See, this is what used to happen and still happens pretty frequently, that the vast majority of test subjects tend to be college students because that's where the research is, right? It's at colleges. So let's say I'm testing my drug on young, white, affluent men. I might not know how it affects women or people who are not affluent or people who are not white. So I have to make sure that I have a representative sample of the population. So I have to find the population of the United States. Let's say there's I don't know the actual statistics, but let's say 13% are African American, let's say 10% are Latino, let's say 4% are Asian, 50% or 51% are women, all these things. That has to be the same makeup as my representative sample of the population of my test subjects. I have to represent that population in my test subjects. So I have to have more or less the same percentage. So I can't have 90% men, for example. It has to be about 50-50 men and women. A good example would be politics. Let's say I want to poll, I want to find out about the upcoming elections and I want to predict. So I poll everybody I only poll people in my neighborhood. Well, politics tend to break down around areas. What if you only, polled Seattle in order to know about, the presidential elections? That would really throw you off because Seattle is 90% liberal. But that wouldn't give you a sampling of the whole country. that would be a bad representative sample, and you would get invalid results. So those are some important concepts, and I'm going to stop this video now.